In the last class, we have talked about threading, and we have seen that what do you mean by a thread. So what we have discussed is we have, let's say, a program, and a program has many processes, and many processes has many threads. So we have a program has many processes, and one processes may have different threads. And actually in CPU utilization, thread is the entity which utilizes the CPU. So a process may have one thread or may have more than one thread. So if a process has only one thread, that is called single threaded process or high weight or heavyweight process. If we have multiple threads in a process, so that model is called multi-threaded process. And in this, every thread has their separate register and stack. Code data and the file will be shared between all the threads. Then we have, then I shown you one example where there is a process, and when we'll click the process, you'll find out many threads. Thread has the properties like they have the IDs, they have the status of them, they have different stack, they have different registers. So all those things has been shown here in this particular example. The benefit also we have seen, like if we have threads instead of process, so we can have very responsive system. We can share the resources. It will be very economical, and scalable or utilization of multiprocessor architecture will be possible if we have multiple threads available. Then we have seen the concept of data parallelism or task parallelism. I told you about in the single core how concurrent execution will take place, and what happened in the parallelism. So parallelism and concurrency, about that we have seen. So concurrency mean in a single core, if we want to concurrently execute the process, so we have to take the task one by one, give them the time slice like a round robin, and we have to execute the task. In the parallelism, we can do it parallelly. We can run more than one task in multi-core processors. Now, after that, we have seen different threads model. So many to one, one to one, many to many threads model we have seen. We have seen the advantages and disadvantages of many thread models. So in this particular thread model, if one thread used to block, so what will happen is all the kernel thread will be, so there is only one kernel thread attached with all the different threads which are available in the system. So if we are creating a thread or user is creating threads, so all these threads are mapped with one kernel thread. And if one thread is calling the block, then then the kernel thread is going to be blocked, and all other thread which are actually executing normally will be also blocked. That is a disadvantage of many to one. But the thing is that it is a lightweight, and we just have to create the user thread, and kernel, only one kernel thread has mapped to it. So one kernel thread will take care of all the user threads. Now, if we'll do one by one, here one thread is associated with one kernel thread. So in this particular model, if one thread wants to block it, only one kernel is going to be blocked. All other kernel will execute normally. But in this system, depend upon the threads, we have to create the kernel thread. It will become a very heavyweight, and your system will become very slow. After that, we have many to many model. In this, we have n number of user thread, and to map them we have m number of kernel thread, where always n will be equal to or greater than m. So m should be always less or equal to. So in this particular scenario, what will happen is, even though we are creating number of users or number of user threads, uh, it will not create as much kernel thread. It will be less than that. So now definitely it will reduce the load of the system, as well as if one thread used to block, so associated only one kernel is used to block, all other kernel is going to be execute normally with all the threads. So it will not going to put your system in the block state, or it will not put your system into the hang state. Then we have two-level model. Here we can have M to M and we can have one to one. So we may have these type of model also. It is similar to that. It is called M to M model. Here expected that it allow a user thread to be bound to the kernel thread. Here what we are doing is, every kernel thread should be bound with any of the any user thread could be bound with the any of the kernel thread. That is the thing. Or we can have these type of model available if we have less number of threads available in the system. If we have many number of threads available in the system, then this model is going to work. So it will be interchangeable model that we'll use here. That is called two-level model. Either we'll use this if load is less. So one thread, one kernel model, one kernel thread will be created. For n number of user thread, we have m number of kernel thread will be created. So these are all different operating system which generally use two-level model. Now in today's lecture, we are going to see another concept which is called hyperthreading. So we have seen the concept of multi-threading, where multiple threads, how they are going to execute into the system, and what are the different model that we'll use for the user thread and the associated kernel thread, that how they are mapped together. Now let's talk about hyperthreading or simultaneous multi-threading model. So simultaneous multi-threading means we have multiple threads available. Means we have multi-threaded model, but these multi-threaded model execute simultaneously. How it is possible? That if we have multi-threaded system, that is okay. That one process, there is one process, and this one process are creating multiple threads. That it is okay. That is a multi-threading model where all the user thread will be mapped with the kernel thread. That is okay. But the thing is that if we have two threads available, let's say thread 1 and thread 2, then how these two multiple thread will execute into the CPU concurrently, means how these two thread is going to execute into the system concurrently or simultaneously. So this concept is called simultaneous multi-threading or hyperthreading. Actually, hyperthreading is the name given by Intel company when they created their hyperthreading CPUs. So on that note, they have made a name called hyperthreading or hyperthreading technology. They say these type of technology is called hyperthreading technology. Let's see this, what is that technology is, and try to understand what they mean by hyperthreading. So in the hyperthreaded system, it allow their processors cores resources to become multiple logical processor for performance. What it is saying? It is saying that if we have a process core available, that particular resource will become multiple logical cores or virtual cores. So we have a physical core available. Let's say we have only one core of CPU. And when we apply hyperthreading, so what it is expecting is we have the same CPU, but logically it is dividing into different cores. So we have logical CPU available, means we have more than that available CPU. This is the physical. Physically we have, let's say, one CPU available, but logically we have multiple CPU available. In that, what will happen is we have only one CPU, but we have divided the CPU logically into two CPU. So one thread will execute in one logical CPU, another thread is going to execute in another logical CPU. In that way, both the thread will execute simultaneously into the system. That concept is called hyperthreading concept. Okay. For that, to support the hyperthreading, we should have the proper operating system which can do that, as well as we should have the proper hardware, that is your CPU. We should have the CPU which will allow multi-threading, and we should have the operating system which will support it. It enables the processor to execute two threads or set of instruction at the same time. So what it is saying that it enables the processor to execute two thread or set of instruction at the same time. So at the same time, two thread or set of instruction will execute into the CPU simultaneously. Since hyperthreading allow two streams to be executed in parallel, it is most likely having two separate processors working together. So if two logical unit are considering as two different CPU, so we generally we assume that we have two CPUs instead of one CPU available. So to see that in practical, in Windows, we have some commands in which we can see that how many processor core you have and how many logical processor you have. So what will happen is in today's computer, we may have different cores, right? We have one CPU. Generally, we have one CPU in desktop and in the laptop. And in one CPU, we may have different cores. We have a dual core CPU, we have a 4-core, we have octa-core CPU. So we have different cores available. It is the physical cores which are available. But do our operating system and do our CPU supports logical processor? So to see that, in Windows, we have these commands that we have to follow. So what we have to do here is we have to use wmic. It is Windows management, some Windows management, some instruction console was there. When we run this particular command, it will go to that CLI, and then you write the command CPU get number of cores. So when you execute this particular command, you will get how many cores your CPU is having. Okay. And after that, you can run another command which is called number of logical processor. Number of logical processor. When you run this particular command, it will tell you that how many logical processor it has. So you see, in this particular system, there are two cores, which is the physical system we have, but it is supporting 4 logical processor. So physically we have 2 CPU, but logically it is making 4 CPU. So we have one CPU which has physically 2 cores, but it is making logically 4 cores. So 4 thread T1, T2, T3, T4 can execute in this particular CPU. So that concept is called hyper-threading. Let's see the same thing in my system, that how many cores are there and how many logical cores are there, or how many logical processors are there. So for that we have the command that we have to follow. So the first command is, okay, so first command is system profile SP hardware data type. So that will type in the console. So I have opened the terminal here and I am going to write this particular command here. So this is the command that I am typing here, system profile SP hardware data type. Okay, so now it is showing me the whole configuration of my system, that the model identifier, the speed of my CPU. We have Intel Core i5. Number of processor is 1. Total number of core is 2. So I have only 2 core, dual core CPU. All those things are there. Let's talk about the physical processor that we have. So for physical processor, we have the command syscontrol /n wh, which is hardware dot physical CPU. So when we'll run this particular command, it will tell me 2. Okay, so let's clear it and just write the same command again. See what output I am getting. I am getting the output 2. So I have 2 core, which was already there, I know. Let's say we'll talk about the logical CPU. So I'll write syscontrol -n whw dot logical CPU. So how many logical CPUs are there? So you can see it support 4 logical CPU. So that thing also you can see by your in your system. So what is that? The meaning is my system support hyperthreading. So hyperthreading technology will be supported in my system. Why? Because the number of physical cores are 2 and number of logical core are 4. It means that it is giving me 2 times logical CPU, and so I can run 4 simultaneous thread at a time. So in that way, I can say that my system is more multitasking.